Hello everyone, welcome to this video on optimistic rollups. Optimistic rollups are scaling solution for blockchains designed to enhance throughput and reduce cost. They achieve this by leveraging off-chain computation and batching transactions to improve overall performance. Essentially, optimistic rollups assume transactions are valid and only change them if fraud is detected, leading to greater efficiency. Optimistic rollup functions by processing transactions off-chain, utilizing a network of validators to execute and verify transactions in batches. This significantly speeds up the transaction processes and resulting in a more efficient and scalable system. However, it's important to note that this relies on the assumption that all transactions are valid to address potential fraud or malicious activity. A challenge period is introduced. During this period, anyone can submit fraud proofs if they suspect a transaction is invalid. To get started with developing an optimistic rollup application, you need to set up your development environment, beginning by installing Node.js, which provides a runtime environment for executing JavaScript codes. Next, choose a framework like Truffle or Hardhead for building and deploying smart contracts. Install the necessary libraries, dependency, and web3.js library for interacting with the blockchain. First, install Node.js from the official website, and it is crucial for executing the JavaScript code. The Node package manager for managing dependencies and installing packages. Next, install Truffle or Hardhead global using npm. And finally, install the necessary libraries like vector.js and etc. You can do this. You can add the Truffle using npm install gtruffle hardhead, or you can do that for Hardhead also. So now let's create a new project. To create your optimistic rollup application, start by initializing a new project using Truffle or Hardhead. Use the truffle init command to set up a basic project structure, which include directories and contracts, and then configure the project's environment, including network settings and compiler options to match your development needs. Then the simple rollup contract uses a mapping to store user balance and includes deposit and withdraw functions for managing funds. These functions emit events to track deposits and withdrawals. The deposit function receives Ether, increments the user's balance, and emits a deposit event. The withdraw button verifies the user balance, decrements the balance, and transfer funds to the user address, emitting a withdrawal event. These events provide a transparent record of all transactions within which is crucial for auditing the optimistic rollup system. Here is the example of a basic simple rollup contract written in Solidity. This contract includes mapping for user balance and functions for depositing and withdrawing funds. Events are emitted to each transaction to ensure transparency and traceability. This is a very basic code. You can easily understand it as we have done more advanced code in the previous videos. Now, when we come to the deploying of the contract, deploying the optimistic rollup contract involves compiling the Solidity code and deploying it to a testnet. Use the truffle compile command to compile the code into bytecode, which can be executed on the Ethereum virtual machine. Configure the truffle config.js file to specify the testnet you want to use, such as Ropsten, Kovan, or Ringfly. Finally, use the truffle migrate command with the dash dash network flag to deposit the contract to chosen testnet. So this was the code I was telling. To deploy the testnet, you should use truffle migrate dash dash network hosting. To interact with the deployed contract, first connect to it using a JavaScript library like web3.js. Create a web3 instance and use the contract's API and address to initialize a contract object. You can then send transactions to the contract's methods, such as depositing and withdrawing funds. Additionally, you can listen for events emitted by the contract to stay informed of important changes. These interactions are crucial for managing and auditing the optimistic rollup system. Here's an example of code for interacting with the contract using website.js. This code snippet shows how to connect the contract, send transaction for depositing and withdrawing funds, and handle events emitted by the contract. Here are two basic functions for withdrawing and depositing the amount, and we use web3.js library here to perform this function. We'll have to necessarily implement the fraud proofs. The challenge period is a crucial element of optimistic rollups, providing a window for dispute resolution. During this period, Anyone can submit fraud proofs if they suspect a transaction is invalid. Fraud proofs are cryptographic evidence used to validate or invalidate a transaction. After a fraud proof is submitted, the network verifies its validity against the rollup state and the underlying blockchain. If the proof is valid, the transaction is rolled back, ensuring the rollup's integrity. The code snippet showcases a simple implementation of fraud proofs within an optimistic rollup contract. It defines a rollup fraud proofs contract with functions for depositing funds, submitting fraud proofs, and withdrawing funds. The submit fraud proof function allows user to submit cryptographic evidence challenging a transaction's validity. The withdraw fund function incorporates a check for the submitted fraud proofs, ensuring the rollup's integrity. Here is the example code we can look upon. Here is the contract roll up with fraud proofs and the events which are deposit and withdrawal and the function which is deposit. And here are the remaining two functions which are submit fraud proof and withdraw function. You can easily understand these codes as we have done these earlier. Handling deposits and withdrawals involves on-chain and off-chain processes. On-chain deposits involve transferring funds directly to the rollup contract, which records the deposit and updates the user's balance. Off-chain transactions are processed by a sequencer that aggregates them into batches and submits them to a rollup contract for verification. Withdrawals are finalized on the blockchain after the challenge period, ensuring only valid withdrawals are executed, maintaining the optimistic rollup system's integrity. Connecting to an optimistic rollup network involves configuring your development environment and setting up a connection to the network's RPC endpoint. Different networks have their own configurations, such as Optimism and Arbitrum. For development, a testnet is often the best choice, while production developments should use a mainnet for security and stability. The example code demonstrates how to connect to the Optimism network using Web3.js. By establishing a connection to Optimism's RPC endpoint, your application can interact with smart contracts deployed on the Optimism chain. Now we'll look at the code. So this code uses Web3.js library and it has a simple asynchronous function which is to connect. Now, monitoring rollup transactions are really important. So, it is crucial. It is crucial for tracking their status. Various monitoring tools such as Etherscan and Blockscope provide real-time insight into the network's health and activity, displaying transaction history, block information, and other relevant data. Security is paramount when integrating optimistic rollups. Ensure through code audits, implement robust fraud-proof validation mechanisms, and follow best practices for secure integration. Use secure libraries, validate data before processing, and implement access control measures to protect the system from attack. Follow best practices for secure code writing, including input validation, output sanitization, and secure coding techniques. Conduct regular code audits and comprehensive testing, covering all potential use cases and edge scenarios. These practices ensure the functionality and security of your optimistic rollup system. Choose a suitable testing framework such as Truffle, Hardhat, or Foundry and integrate it into your development environment. Write comprehensive test cases to validate your contract's functionality and security. Utilize debugging tools provided by your chosen framework or IDE to effectively troubleshoot issues in your contract. Optimistic rollups are constantly evolving with several exciting advancements on the horizon. Enhanced fraud-proof using next-generation cryptographic techniques, improved layer 1 integration for better incorporability, and expanded use cases for DeFi gaming and NFTs are some of the future developments that will further enhance this technology capability and adoption. You can also see the real-world application which are being done using the optimistic ruler, including DeFi platform for faster and cheaper transaction, payment solution for secure and efficient payments, and gaming and NFT marketplaces for scalable and profit cost-efficient transactions. In the conclusion, optimistic rollups offer a promising solution for enhancing scalability and improving the user experience within the blockchain ecosystem. We encourage developers to experiment and stay updated with the latest advancement in the rapid evolving technology. Thank you for your attention.